This video is dedicated to FreeCAD's new assembly workbench only. The other day I went to my case and look what I have found. It's a book, Engineering Graphics, second edition, and this is all about how to draw mechanical drawing by hand. It's a very resourceful book and it has a lot of things. It actually reminds me of my first couple semesters in my college where I had to do all these by hand drafting. Look what this is. Alright, so here it is. This is the original receipt of this book. It's from 1980 and it was $25.25. UT Book and Supply Stores. It also has the original tag and it does say something about, so 1980 I can see that, and department 60601 or 501 rather, class 0, and $21. So $21.95, there is that, and that is also reflected on this receipt, $21.95. Anyway, I am pretty happy that I have this book from 1980 and it looks almost new to me, so pretty pristine condition. And one of the models in this book is this any angle tool Vise, figure 14.118, and that is what I am going to build today, or rather do the assembly today. To keep the video at a minimum length, I went ahead and built the model already. So what I will be focusing on primarily, as I said in the beginning of the video, on the assembly workbench of this FreeCAD. So today I'm using the next release after the FreeCAD RC1. So there was a release candidate 1 released last week, and this week there is the next, I think, developer version, weekly build 1.1.0 developer version. It's the same thing as the release candidate 1. So that's what I'll be using, and I'll quickly go over how I build this part just a little bit, and then I'll start on the assembly workbench. I will upload this video at the end of this session on my on-cell lens library, so you will get your hand on this model. You can download it and then play on the sketching and everything else, so don't worry about the dimensions right now. With that, let's go ahead and delete the assembly that I built, right? And then let's go over the parts that I built. So the model on the book has 9 parts, and the number 9 is the scale, the steel scale. That's something that I don't want to build. So I have built all the 8 components, and all of them are stacked in here because I built all of those taking the origin of the workbench, origin of the workplace as the parts origin. The first one is the saddle. That's where everything will sit on. It has primarily 2 parts. This is the base, this is the rotating part. So if we get inside there are a lot of fillets, but the main part is right here. Let me hide that. And so this is the base, that's the first, and sketch is pretty easy. That's a standard square rectangular base, and then there is this part to make that notch. So I built that and then mirror it over on the other side, and then use the connect feature of the part, and then that kind of like notches is up. So, and then this is that top part with the holes built inside. So putting everything together, this is our first part, the saddle. Right, that's where everything sits, right? And then the second part is this this rotating, that will be sitting on the saddle, so it has the same radius of this curvature. And on top there is another curved area that will focus on the transverse of the original curve. So this will sit on that first saddle, and then there is something else will sit on here, but they are on the transverse direction. And that part is the upper compound member. So this will sit on the middle part, and then this will hold the part holder. Right. So these are pretty simple, and this is the sketch for that main sketch that will extrude both sides to build this, and then there is a hole in the middle. So this is the hole in the middle, and cut it out to build this part. And the next part is this compound tool holder. So the circle that with the circular hole we just built in this here, so this is the same diameter that's here. Notice how there is a notch at the middle. A bolt will come through here and then tighten it up or like loosen it, so that will be hold in place. You cannot pull it out from that hole. And then this is where the tools will go. The tool holder that we are building, the tool will go in right there. Right. And as you can see, these 4 holes, they should be threaded. I just didn't build the thread inside, so the computer doesn't die to do that. So these 4 screw will be tightened to hold the piece, and given how these are not like parallelly moving, they can be moved individually, so the part can be irregular. Alright, and then these are restraining parts that will just restrain the movement of that, so not so important for our assembly, but I built anyway. And then this is the locking handle. So there is this eccentric rod that will be rotated with that locking handle and kind of tighten it in place. So these are the pretty simple, and I think for today's demonstration these 4 pieces are the most important. These are needed in the reality to build that. With that, let's go ahead and start our assembly. Again, this is for the new assembly workbench that FreeCAD 1 version is coming up with. So if you are using A2 Plus or like assembly 4 workbench, this assembly may not work on that. So the new assembly workbench is not compatible with the old ones. And also, if you have the assembly, the new assembly file, don't open it up in the FreeCAD 0.21 version. That will mess up things. With all of that, let's go ahead and start our assembly by creating an assembly A, right? And then so this is my 3rd, 4th, 5th video on the assembly series. And as I mentioned earlier, so double clicking on this assembly will deactivate or activate it, or just right click on it, active object. We need this one activated. So now it's not active. So you can see that tick mark is gone. If there is no tick mark right there, you have to activate the object. Now you can see there is a tick mark there. After that, we start inserting our parts. So the parts doesn't have to be in the same file. I can create a new file and then add my parts in there. So that's one way to do it. I prefer keeping that in the same file, and that's one of the reasons why I have all of these hidden, because I'll be adding them in the same file and I don't want to get confused. So hide all of your parts and then name them accordingly, and then start adding or like inserting components by pressing I or this button in here. First of all, I want to add number 1 saddle. That's my base. I want to add it and it will be fixed by default. If it is not fixed by default, the setting, you can go ahead and then set it up so the notification will show up, say yes to that. So there needs to be at least 1 part grounded, like fixed and in place. And so let's go ahead and add that one as my first part, right? After that, I want to add the second component. So pretty easy, the window is still here. So if you had like hundreds of parts, you could search through it, and that's why naming the parts is very important. pretty important, so you can identify which part you are adding through, because there is no visual help in here. All right, so number 2, just added 1, and it says 1 inserted, and now I can actually move it around. Looks like a good spot, and I can keep adding these, but I want to go one by one. So I added this part. As you can see here, it says number 1 saddle 001. That's my first part, grounded part, and I can see that joint in here. That's the first grounded. I can actually go ahead and hide that. And then second one doesn't have any joints in here. I want to go ahead and then apply a revolute joint. The revolute joint is something like a bearing, or like where it will be fixed in place, but it will allow rotation. So if you press fit a bearing, so it will allow rotation by on the axis, but it will not move any laterally. And that's what we want to apply between these two surfaces. And because I built them with the width in there, and so I can go ahead and select that bottom surface. You can see right in the upper side of the right somewhere here, you can see the local axis showing up. So I want to keep that in mind. Looks like it's in the middle, so select that, and also select this one, the second one, so that one there. So it fits in perfectly because these are the same length, and then it's taking the middle point as our mating point, so to speak, and that kind of fits in perfectly there. So now we have our first joint in the model where it rotates all the way around, which is very impractical. We want to rotate it from here to there. That's our rotation target, right? I don't want to go all the way around. So to do that, what I want to do, I want to go back to the joints. See, this is my revolute joint. One thing that I cannot do is renaming this part. So I wish I could rename that as my first revolute. I do that and that goes away. So renaming that doesn't work. Hopefully it will be an option in future models. But now, so remember that it comes sequentially. So this is my first revolute, and I get into there, and there is this minimum angle and maximum angle. I want to apply those. So angle is kind of funny in here. And first of all, you cannot, so you can see now we are at 11.28 angle, and then on this side it becomes minus 11.60. So what it means is like this is my around 12 degree, this is my minus 12 degree, and I would not go in there and then type it in. That kind of creates an issue. So what I would want to do is I want to bring it on the minimum side first, right, and then check on this. So that actually takes that minus 12.29 as its value, which is good, but I would not go in and then type it in to begin with. I can round it up right now, make it minus 12, and then what I want to do, I want to rotate this. It is maximum angle, and I don't know why this side is the maximum, this side is the minimum, and it varies from object to object. That's why it is important to do it from this view. So maximum angle is plus 11. I can now go ahead and make that 12, so that's allowable, I guess. And okay, so those limits are there. Now I should be constrained when I try to move it so it's not moving all the way around. Exactly where we want it, it's right there. So that is our first rotation. That's our first joint. Now in practice, we need some restriction. We need something to prevent it from going sideways, and that's where this upper plate and lower plate comes in. We don't need it for this assembly because the assembly joint is kind of working fine. It's not moving laterally, but let's go ahead and add that, see how it feels like. So on the, now we want to say lower plate because it's on the lower side. So lower plate, I guess that's it. I want to add 2 of them. Right, and now you can see it's kind of mixed up in there. I can grab it and then take it outside, and this notch is built in because there will be scale in here, say 0 to 15 degrees, and we want to read that when it is fixed, and that's why this notch is here. So that notch goes on here. With that, this hole right here will be matched with this hole. I want to fix it, or I want to apply 2 revolute here. So let's go ahead and fix it. So take this point and take like that circle and take this circular edge and make it a fixed. So for fixed, it is important which one you are selecting first. I don't want to select this one first because the first selection is the stable part and the second selection is the moving part, because one of these will have to move to come to one like at the same position. So select the stationary first and then select the moving part second, and then hit fixed joint. See, it kind of like puts it inside there. We don't want to like that, so click on this, reverse the direction of the joint, and that's where we want it. Hit OK. So because it's a fixed joint right there, we don't want to worry about this here. It's already fixed, it's not going anywhere. So that part is kind of fixed, it's not moving anywhere, and we want to do it on this side as well. On this side, I want to apply differently. Instead of 1 fixed, I can apply 2 revolute. It will still work at the same. So take this and take this and say it's a revolute joint and flip the side. Right? So that's a revolute joint, means it will be rotating something like this. I want to say I want to fix it in here too. So take that circular edge, this one and this one, apply another revolute joint. So 2 revolute joint on the same plane kind of fixes it, so it's not moving anywhere. So that's also another one, kind of like a hidden trick. If comes to a point where you don't want to apply a fixed joint, you can apply 2 revolute joint, it will still fix it. All right, so there it is. The piece is moving, and we can see that there is a hole and there is a slotted here that will actually allow the movement up and down. And we have a piece for that. That's an eccentric piece. So that's it right here. Let's go ahead and insert that. I'll apply 2 of them, right? And I don't see where they are. So one way to deal with that is select one of these and move it upward. Select the other one, bring it outside. Now I can see it. Click somewhere else to take that selection away. So now we can see this is an eccentric. This thicker part will go inside right there, and then you can see this slot is kind of smaller diameter than the thicker part. So I can take this one, put it inside there, right there. So I want to do is I want to take this edge and take this edge and make it a revolute joint, and just like that. So looks like I built, oh, maybe it would be flipped. Yes, something like this. So the thicker part will get inside, the smaller part will come outside. And as you can see, it is almost touching here. I guess this should have been a little bit bigger. Let's go ahead and fix that on the eccentric part. So this is the 7.5 millimeter radius diameter. This is 6. So this 6, let's make that 6.25. See if that makes any difference. What I want to do, I want to make this circle touching this edge. Yes. So what it does is if I rotate this, now that we did the editing in there, the assembly has become deactivated. So activate it again. And now, so that is a revolute joint right there. I want to rotate this. So you can see if I rotate like this, now it is free moving. It's moving, it's not touching the slot, right? And now if there is one way, I can actually rotate it backward. And you can see this cylindrical, this shaft is touching the slot. So there should be some friction, right? So if it is strong enough friction, this part will not move anymore. So that's the locking mechanism, right? And that's why this eccentric part comes into way. So we need another part that will be making this rotation here, right? So there should be a lever. So let's go ahead and take that lever in here. So that is 7, yes, locking handle. Let's go ahead and add one more because we'll be doing the same thing on the other side too. So there it is, that's our lever. And this hole should perfectly fit on this outside. So I'm gonna go ahead and take this and make it a, all right, so it will be fixed joint. So take this first, take this second, and make a fixed joint. Flip it up so it goes on the other side. All right, now I want to make it something like this. So that's kind of locked. This is unlocked and this is locked. So that's one way to do it. All right. So we got that. That is our locking mechanism on one side. Let's go ahead and do that real quick on this side too. All right. So we have our lower part of this model built. So this locking mechanism will prevent it when we want to fix it and allow the movement when we want to move it like this. All right, pretty cool. So we will do the same thing on this middle part, the same idea. So I'll take a quick minute to add this piece and speed it up. All right, so that was a quick minute, but we built our second part where this one is moving, and then we can actually lock it up right there when we don't need. When we need it, we can unlock it, right? And rotate it and then lock it back up. Pretty cool. All right. So actually this assembly says that we cannot take it all the way around. There will be some conflict. So maybe I'll have to do some angle restriction on this one too, but that's not that much important for now. All right, let's move on to the next phase. Here we will be adding this upper compound member. Nope, not that one. We want to add this compound tool holder. So number 4, compound tool holder, and move it up. Yep, that's what we want. And this is pretty easy. This is built such a way that this edge will be there, and it will be definitely a revolute joint. And just like that, it fits in, and it will be rotating all the way around. I think, actually, hold on, let me take it back. So I think this will actually get in there. So this is 25 millimeter diameter radius, and this one is 25 as well. I think this was built so actually this edge will be matched with this edge right there. So it will be sitting flush with this surface, and then do its rotation. Now technically this is true for flip side as well, so I'll have to actually think about how I can make this piece all the way always up. But if I try to mess it up enough time, this part goes out inside this one. I don't know how to fix that for now. There must be some way. All right, and I think that's all about this model. So we fix this on a bench and then use this to catch a tool at any angle we need. Very versatile, and that's why the name is Any Angle Tool Vise. All right, folks, that's it for this assembly. Actually, before I forget, let's go ahead and save this and upload this whole thing on cell. Before I do that, can I add different color? Oh, I can, but it kinda, so that's one color. That way it would actually, oh, that's not the color that I wanted to. So random color, maybe another random color. That one, and this one, let's add a different color. So that way now I can see different parts. So now I have different pieces at different color. That way it's easy to actually differentiate which piece is moving and which is not. Let me go ahead and upload it on cell, save it, and then I'll be going to lens.oncell.com, and I have an account over there. They gave me top tier account so that I could upload models in here. So I started uploading my 200 3D CAD models library in here. So go ahead and check it out. So what I want to do, I want to upload this thing, and it will create a mesh in there. So if you are trying to look at this model from your browser, you can do that without downloading. But if you want to download it, you can download it as well. I would encourage you to download it and then try to mess it up, so that way it's a good practice ground. All right, and one thing I noticed is like the color is gone, but the model is there. Let me know if that color that we just assigned in different pieces, when you download it, see if you can see that on your end. On cell, you can take a look at this model as exactly as what we saved in there. The assembly looks like it doesn't work here right now. You can just view it, and then you can download it and then try to work on it yourself. All right, folks, that's all for this model. I hope you enjoyed this. If you have any question, comment, suggestion, or any other discussion regarding FreeCAD, please let me know about your thoughts in the comment section below. And also check out my other models on assembly workbench that I've been doing in the last several weeks. Thank you for watching. I will see you next time.